Welcome to Brain Vision.
Question: we have three sinusoidal waves that's identical, and they travel along a string in the same direction on the x-axis. They have different amplitude, and then they also have different phase constants. Part A, we would like to part A and B is we would like to figure out ways the amplitude is a phase constant of the. Part C, we want to plot a waveform. Okay, so we want, in order to find that, let's use a method of phasors. The first has an amplitude. Wave has an amplitude of 2/2, y1 over 2, so like half the length, and it also has a phase of 90 degrees. So the surface of 180 degrees, and it's y1 over 3. Second wave will be here. It's a value of all three waves, and this form a trapezoid that we can calculate. So part A asks what is the amplitude? Well, we can find the amplitude if we find what different sides. So this is y1 over 3. This is y1. If we write, this will be 2 times y1 over 3. This is y1 over 2. So I just call it ym, y prime, y prime square root 2y1 over 3 squared plus y1 over 2. So this is 2 square root over 4 plus 1 over 36 of 25 is actually equal to 5 over 6 over 6 times 1. And second, to find the angle, the phase, so the phase difference phi equals arctangent of y1 over 2 of 2y1 over 3. Arctangent of 3 over 4. This is roughly 37 degrees. Now we can write out if the resultant of y equals the magnitude is 5 over 6 sine kx minus omega t. 30. Let's put it in radians. It's 0.64 radian. Phase shift is 0.64 radian. So finally, for part C, the question wants us to graph it. This is something that you probably need to use a graphing. This is y1, and this is probably ym. Similarly, if this is y1, this is roughly ym. And if you use a calculator, you can see the phase shift looks something like this. The origin looks something like. Alright, is how, and if you're careful, you can also mark where the this will be 1, this will be 2. So that is all 3 parts of this question.